Okay, we're going to simplify by distributing this, and when we distribute that, we multiply this times this, and since they're both in the radical, we get 3 times 12 is 36 inside of the radical, minus, when we multiply this times this is out of the radical and this is in, so when you multiply them, you just stick them together like that. And you always write the number outside the radical first. Now we can simplify this by square rooting 36 to get 6, so we end up with 6 for the first part, minus 4 root 3. These are not like terms, so they can't be combined. So that's the final answer. Okay, I'm going to distribute this, but instead of actually trying to figure out what 5 times 125 is, what I'm going to do is I'm going to leave it in factored form. I'm going to say that this is going to be 5 times, I know this is 5 cubed. So I'm going to get square root of 5 to the 4th. And when I take this out, I'm going to get 5 squared, which is 25. So that's the first part. And then when I multiply this times this, I'm just going to get 6 root 5. Now you could have multiplied 5 times 125. The reason I didn't is because I didn't want my numbers to get too big, just to turn around and make them small again. So I left it in factored form, which was easier to do. So I'm going to distribute this, and I'll get the square root of 18 times 2 is 36, which becomes a 6. And then when I multiply this and this, they're both inside the radical. 2 times 3 is 6. And these are not like terms, so they cannot be simplified. That's the answer. Now, you could multiply 5 times 15 if you want, but your number gets kind of big. So instead, I'm going to factor this and make this 3 times 5. So when I multiply this times this, I have the 5 from the outside and the 3 times 5 from the inside, and then these two come out as a single 5 because that's 5 squared, and when you square root it you get 5. So you end up with 5 coming out times root 3. Now that's not the only way to have done it. You could have multiplied that and got 75, factored 75, you'd still get this. Anyway, when I multiply this times this, root 5 times root 5 is simply 5. Those are not like terms, so that's your final answer. These two binomials are conjugate pairs. Whenever you multiply conjugate pairs, it's always the square of the first thing, which will give you just 6, minus the square of the second thing, which will give you 4. 6 minus 4 is 2. These binomials, again, are conjugate pairs. Whenever you get conjugate pairs, you have the square of the first thing, which is 7, minus the square of the second thing, which is 64. 7 minus 64 is negative 57. Again, we have conjugate pairs. When you multiply conjugate pairs, you get the square of the first thing, which is 12, minus the square of the second thing, which is 3. 12 minus 3 is 9. These binomials are conjugate pairs, so when you multiply conjugate pairs, you get the square of the first thing, which is 18, minus the square of the second thing, which is 8. 18 minus 8 is 10. Okay, we just have to multiply these binomials together by foiling them. The first is root 3 times root 6, which is root 18, which is square root of 9 times 2. When we take out the 9, we square root it, becomes a 3, so we end up with 3 times the square root of 2. That's the first. Then the outer is this times this, which is just negative 5 root 3. And we can't simplify that, so it's just writing it like that. The inner is this times this, which is just a plus 2 root 6. And we can't simplify that. And finally, the last is this times this, which is a negative 10. None of these are like terms, so they can't be combined, so that's the final answer. Okay, we have a binomial times a binomial, so we'll FOIL it. The first is root 7 times root 2, which is root 14. The outer is root 7 times negative 4, which is a negative 4 root 7. The inner is 1 times root 2, which is a positive root 2. And the last is 1 times negative 4, which is a negative 4. None of these can be simplified, and none of them are like terms, so that's our final answer. These binomials are conjugate pairs. Whenever you have conjugate pairs, it's always the square of the first item, which is just 3x, minus, it's always minus, the square of the second item, which is 4. Those are not like terms. They cannot be simplified, so that's your final answer. These binomials are conjugate pairs. So when you multiply conjugate pairs, you get the square of the first thing, which is 6y, minus, it's always minus, the square of the second thing, which is 16. Those are not like terms. They can't be simplified, and that's it. Okay, these are identical binomials, but they have opposite signs, so they're conjugate pairs. So whenever you have conjugate pairs, you square the first item. Now when we square this and get 4, and we square the root x and get x. So the square of this whole thing is 4x. And it's always minus the square of the second thing. The square of the square of the square root of y is just y. So we get that. They're not like terms, you can't simplify. Okay, these binomials are conjugate pairs. They're identical with opposite signs. So whenever you multiply conjugate pairs, you square the first item and get p, and it's always a minus, and then you square the second item. Now when you square this, you have to square this, and you have to square this. The square of this is 25. The square of this is s, so that's 25s. Those are not like terms. You can't continue. Okay, here we have a binomial square. Whenever you square a binomial, if you remember this from earlier, it's always the first item squared twice the product of the two. The product of those two things are AB, so twice that is 2AB, and then the last thing squared. Okay, so we're going to do the same thing. We're going to square the first item. We square this, we get 16. We square this, we get x. Then we go, the product of these two items is 3 times 4 is 12 root x, but remember it's 2 of those, so the middle item is positive 24 root x, and then it's the square of the last thing. Square of that is a positive 9. None of those are like terms and they can't be simplified, so that's the answer. Again, we're squaring a binomial, so we square the first item and we get 25 and p, so that's just 25p when we square the first item. The product of these two items is negative 30 root p, but remember you have 2 of those because you have an inner and an outer, so we're going to have negative 60 root p, and finally you square the last thing, and any square is positive, so this is a positive 36. None of these are like terms, so that can't be combined or simplified. That's your final answer. Okay, these are conjugate pairs, so we square the first item and get 81, and it's always minus, and then we square the second item. The square of this is the cube root of 2 squared, which is 4, and that can't be simplified because this is just 2 squared. It's not enough to bring anything out, so that's your final answer.